So we are ready. I need everyone to quiet down. Darius, we're ready. Kevin, we're ready. Andrew, get your notes out. Adrian, get your notes out. Okay. Our goal today, we're factoring by grouping. We want to be able to factor a third-degree polynomial, Kevin, with 4 terms. We want to be able to factor a third-degree polynomial with 4 terms. So third-degree polynomial with 4 terms. So we have not talked about the degrees of a polynomial yet. So probably you're like, what do we mean by a third-degree polynomial? Guys, Josh, please. So, what do we mean by the degree of a polynomial? When we talk about a polynomial, the degree of the polynomial is just the highest exponent. The degree of a polynomial is just the highest exponent. It's one of the ways we classify a polynomial, is by saying it's a third degree or a fourth degree or whatever. So if I have 3x to the 5th minus 12x to the 4th plus 2x squared minus 8. What degree polynomial would this be? 5th degree. The highest exponent is a 5. So we're not looking at the coefficients at all. We're looking just at the exponents to name the degree. So this is a 5th degree polynomial. How many terms does this have? 4. We have 1, 2, 3, 4 terms. Jessica. Michael. Okay, so 5th degree polynomial with 4 terms. Sometimes when we count the terms, we can give it a special name. So if it has 3 terms, we could call it a trinomial. Or 2 terms, we could call it a binomial. When there's 4 terms, it sounds kind of awkward to say quadnomial. So we usually just say 4 terms. Or quintinomial, hexanomial. Those all sound kind of weird. So normally we start with the multiplication. This time I'm just going to start by showing you how we do the process. This one it's really hard to see a pattern, so we're just going to go through the process. Now is this a third degree polynomial? Why? Highest exponent is 3. Nicholas is correct. How many terms do we have? 4. So we do have a third degree polynomial with 4 terms. That means we can use the process we're about to do. So first, with any type of factoring, it doesn't matter what process we do, we always check for a greatest common factor. Draw an angry face. Because we can't forget this. Okay. Always check for a greatest common factor. I think that's what I'm saying. Dan? What is my greatest common factor? What divides into every single term? 2 definitely works. They're all even. We could think maybe 4, and 4 would work here and here. Then when we got to 74 wouldn't work. So we definitely use 2. I also check for a variable. Does every term have a variable? No. So we just use 2. So we divide everything by 2. That should be the first thing you do with any factoring problem. 12r squared minus 35r minus 21. 2 times 20r to the third. Darius, please be quiet. 2 times 20r to the third plus 12r squared minus 35r minus 21. Okay? When we factor by grouping, then we need to form some groups. The groups will always be the same. We always take the first 2 as one group, the second 2 as our last group. We're going to consider these 2 pieces separately. 20r to the third plus 12r squared is one group. Negative 35r minus 21 is our second group. So once we formed our groups, we find the greatest common factor in each group. So I know it's kind of a weird process. Like I said, this one it's harder to see the pattern, so I'm just showing you the process. So our 2, it's going to be part of our final answer. The 2 should not disappear, but I'm going to ignore it for now. I'm going to ignore the 2. And I'm going to just focus on my groups. In my first group, 20r to the third plus 12r squared. What divides into 20 and 12? 4, 2, 5 divides into 20 but not 12. 6 divides into 12 but not 20. So it looks like our highest one is 4. And then we also consider our variables. Do they both have a variable?
Yes.
R to the second.
Why the second?
Why did we pick the second?
It's the lowest
It's the last one in that group. It's the last one in that group. So now we divide. 20 divided by 4 is 5. R to the third divided by r squared is r. We divide the other one by 4r squared. 12 divided by 4 is 3. The r squareds cancel. We have the same variable over the same variable, they cancel. So we found the greatest common factor with our first group. Now we go to our second group. What divides into both 35 and 21? 7. Now, if the first is negative, the GCF is negative. Darius, will you move to that back table, please?
Oh.
I asked you like 5 times to quiet down, so.
That was gonna be though.
Okay, so negative 7 divides into negative 35 and negative 21. So now we do that division. We're dividing by a negative 7. So it's negative 35r divided, oh, why didn't I use a variable?
21
Because there wasn't one 21.
Because there's no variable in 21.
Everyone was correct. There is no variable on 21. So we do not use a variable. So now we divide. 35 divided by 7 is 5r. We are positive because a negative divided by a negative is positive. Now we should start to notice something. we're going to get something that's similar. What if we do 21 divided by 3?
3.
So what do we notice that matches?
They're both negative.
Both of these parentheses are the same. We have 5r plus 3, 5r plus 3. If your parentheses do not end up being the same, you are doing something wrong. Every single problem we're going to work with, these parentheses will match. And it matches for a specific reason. We're going to factor this out of the problem. We're literally, just like how we divided 7 out of everything, we're going to divide 5r plus 3 out of everything. But when we divided 7 out of everything, even though we had 2 here, how many did we have left in our answer? Just one of them. So that's going to be the same with our 5r plus 3's. Even though there's 2 here, when we factor out, we only use one of the binomials. Remember, binomial means 2 terms. And then we're going to multiply it by anything that's left over. So we use one binomial, 5r plus 3. Even though there were 2 written, I only write 1. Then we take anything that was left over and put it in our second parenthesis. We have 4r squared left over. We have minus 7 left over. So we have 4r squared minus 7. And then I moved my 2 down too low. The 2 should be in front of everything. That greatest common factor should not disappear. It's still part of our answer. Just like when we do greatest common factor with the box method, it still is part of the answer. So I know it's kind of a weird process, but it's the same process every time. There's not really any tricks in this kind. There's no variations. You do these steps every single time. So we are going to have 2 more examples, and then I will hand out the assignment.
Can you go back?
Wow.
Oh.
Yeah, can you leave it right there?
Well, I assume the person who said, you go back, was looking for this. Yes. So is everyone done writing this stuff down now?
just need the top, like a little bit more.
I will scroll it up in 1 second. I think I still see people writing. Stephanie, what are you doing?
Going to the assembly.
What assembly?
The senior assembly.
Are you a senior?
I just never took this class.
I don't think we have any seniors in this class.
She's a senior.
She is. So we're back to recording. Example 1. Now we're going to do the process without writing all the instructions down. We just have 2 more examples. One where we do the process without writing the instructions down. One where we have to factor out some weird variables as we go along. So we look at this problem. 2v to the 3rd plus 3v squared minus 6v minus 9.
I didn't realize I
And what do I always do first? Greatest common factor. I always greatest common factor first. It's a must. What divides into every single one of these? 1. So again, when it's a 1, I don't technically have to write it down, but I think it's nice to do it the same way every time for consistency's sake. Guys, quiet down, please. Jessica?
No, it's because his leg broke. worth it. Damn her.
Way to go, it's going on YouTube right there.
Damn her.
Okay, we divided everything by 1 because that was the greatest common factor. Now we go through the process. What was the next step in my process? Form our groups. We form our groups and they're always the same. It's always the first 2 and the last 2. What divides into the first 2? 1 V to the second. We use the lowest exponent, not the highest exponent. So now we divide each of these by 1v squared. And when we divide 2 divided by 1, it's still a 2. V to the third divided by v squared is just v. 3 divided by 1 is just 3. And the v's cancel out. Okay. Now, we know that the next one should end up matching. So when we find our greatest common factor, we'll know if we're doing this correctly if our parentheses end up matching. So what divides into both 6 and 9? 3. Should I make it positive or negative?
Negative. Negative.
I'm hearing both.
Negative.
Negative. Why negative?
Because they're both negative numbers.
Because you have
Close.
It starts with the negative.
First one's
It
negative.
starts with a negative. We don't care if the second one is negative. We just care if the first one is negative. So negative 3, and we divide again. So 6 divided by 3, positive 2, because a negative divided by a negative is positive. Negative 9 divided by negative 3 is positive 3. Okay, so now we've done our greatest common factor of each group. Yes?
Where'd you get the negative in the middle? Yeah, I don't get that.
This was our greatest common factor that we divided into the 2 things. You always have to put the greatest common factor in front of your parentheses.
So what if you don't have it? What if you don't have a greatest common factor?
What is the greatest common factor you can use every single time? 1. So sometimes you would have to use a 1 instead. Hmm?
You don't have to put anything. It doesn't make sense.
You would if it's this middle stuff. So in this case, I would always write your 1 out. So now we finish writing this out. Come on, can you move away from Michael, please? So we write our answer. When we write our answer, what do I start with first? Liam. Greatest common factor of these 2, which is the entire binomial. We start with this binomial here. Even though there were 2, it's like when we had square roots. When we did square roots, even though there was 2, 1 died, only 1 made it out alive. It's that same idea. What do I write in my second parenthesis?
So minus
1v2 minus 3. And then my greatest common factor from my original step goes out front.
Wait, where's the 1v2 from?
1v2 got moved into this parenthesis.
No matter what side.
What?
No matter what side.
In the parentheses, we should go from left to right. I could have written the parentheses themselves in opposite order. So that I could switch. But I could not switch the 3 and the v squared. Yes?
Where'd you get the 1v second, first?
This?
Yeah.
Okay, so we looked at just these 2 terms, the 2v to the third and the 3v squared. And we said, what divides into both 2 and 3? Okay, because they both have a variable, I'll make a circle with a different color. They both had v's. we always use the one that has the lowest exponent. Good questions. Thank you for all those questions.
You wrote it differently, but it doesn't matter.
No,
Okay.
this is a second option, but usually I do it this same way every time. Again, to make it consistent. Okay, last example. Last example. There are some weird variables in this example, but it's still the exact same process. William, write down this last example. 18MW minus 30MK, that is a K, minus 3NW plus 5NK. It does?
No.
It's not writing. Letters can. I didn't hear your question.
The letters can't go together, right?
No.
So it's pretty much done.
Well, we could still do the process. We could still greatest common factors and stuff. Okay, so we start with our first step. Always greatest common factor everything. What divides into every single number? 1. So we have a 1 that divided into everything. Again, when it's a 1, we technically don't have to write it on this first step, but if you're consistent every time and do it the same way every time, you're more likely to do things correctly. So that's why I am writing it every single time. So we did our greatest common factor. Now we look for our groups. I know there's some weird variables going on, but we still just group the first two and group the last two. None of our process will change. We're going to still do this the same way. So within each group, we're looking at 18 and 30. What divides into both 18 and 30? 6. We could have thought 3, we could have thought 2, and both of those work. But we want the greatest common factor, so we're going to use 6. And then we also have to consider the variables. What variables do they have that are the same? M. So we're going to use 6M. And in this case, we have an M over M in both of those, so they both cancel. The M's are going to go away, except we take these, what we're dividing by, put it out front of one set of parentheses. So now I divide. What's 18 divided by 6? 3. And what didn't cancel? W. So it's still there. And then we divide again. 30 divided by 6 is 5. And extend the page. 30 divided by 6 is 5.
Oh, I get it.
K didn't cancel. So we leave a K. Now I go to the next one. What divides into both 3 and 5? Just 1. But this will be a -1. Why am I going to use a -1? The first number is negative, so we use a negative. If it was a positive one, I'd put +1. But since it's a negative, we put -1. And then again, we're looking at our letters. What do they have in common? So now we divide. -3 divided by -1, +3. Ends cancel. We have a W left over. So far, things are looking good for us because they're starting to match. +5 divided by -1 is -5. Okay. The ends cancel, but we're left with a K. So now we write our final answer. Our final answer is going to have that greatest common factor out front. Still just have 2 parentheses. What went in the first parenthesis?
3W minus 5K.
3W minus 5K, the one that repeated. We only write it one time. Then what do I put in the second parenthesis? I think I heard Dylan. 6M minus 1. Everything that was left after we canceled out.
I wrote 3 there. Why did I write 3 there?
The n's canceled. N divided by O. Taylor is correct. I forgot to put my n out front here because both of those had an n in the greatest common factor. So it should be 6m minus 1n. Thank you, Taylor. Good eye.